Hi everybody. So last time we learned about trend lines. We added one and you're like, that's it? That's all we're doing? No, we've got a lot more to do, but it's so much that I decided to make it its own little section. So let's jump into equation types because there's so many different types of lines that that Excel can add. So let's look through them all together. So equation types, here we go. Okay, now this is a very big section, so I even made these nice little jump points for you to go down through the data. As a note, when you click on them, it's at the bottom of the screen. I can't fix that, and depending on your screen, I didn't want to mess it up and get you confused. So it's always at the bottom. Okay, so there's always a bunch of options for what can fit your data. However, just trying to find the best R-squared value, the thing that says, how is this compared to an average, is not the right idea. That will end up with a whole bunch of pain and suffering. So let's walk through the different types and see what happens when you use each of them. So the first one is a polynomial function. It's the whole thing like, a plus bx squared plus cx cubed plus dx to the fourth. Just powers of x or powers of z, whatever you want. Excel always uses x. Since this highest order power right here is 5, it's x to the fifth. This is called a fifth order polynomial. A straight line will be a first order polynomial, that would be a x to the first. And technically that average we had earlier was a 0th order polynomial. Now Excel will let you use up to a 6th order polynomial. Beyond that you're going to have to fit it yourself. However, the weird thing is you almost never need a 6th order polynomial. If you're using that, you're probably making a mistake. Okay, so let's look at this right here. Now I've told you what the form of the equation should be. I have added some random error here so that it won't fit perfectly. But let's try it out. Okay, so we are going to fit this. And once again, when we're done, we're going to type done in this little highlighted box. We can actually get that nice good for doing it. Okay, so I click my data, all got highlighted. I right click it, add trend line. Now if I look over here, currently I've got a linear fit. That's pretty horrible. But you can see that this is a third order polynomial. I've got x cubed right here. So I look around, trend line options, and there it is, polynomial. Second order, fits pretty good. And if I go up to third order, well, it fits a little bit better. Let's see how much better it is. So display equation on the chart and display R-squared value. Okay, because of the noise, this isn't fitting perfectly. If I go down to a second order polynomial, 0.8289, go third order, 0.301, just a little bit better. You can also see that because of that error, this equation is not the same form as what I had earlier. This is 20, this is 20.362. This is 4, this is 4.5, this is 3.7, that's -5. And this one was supposed to be 1, but it's 0.3929. That's all because of the error. No error, it would fit it perfectly. So something we have to think about is that you will have error in your data. And so even if you know exactly what form the equation is supposed to have, those constants might be a little bit off. And sometimes it's not going to look as nice as you might hope. Okay, so let's go ahead and delete that trend line because, you're going to come back through and do this. And I'm going to click done. I typed done with an exclamation point because I'm a doofus. Done. There we go. Okay. So, now if you look at it right here, this was a really small range. That was from 0 to 1.2. What happens if you expand that range a little bit? What you're going to see is that it jumps up incredibly. Like if you look right here, can you actually tell the difference between these 3 points? They're not all 0, and yet they all look like 0 because it's jumped so much. In fact, this number right here is 6,110. You can't tell it's not 0. And also, this is jumping like crazy. You can't really guess where it's going to go next. Now, this would be extremely difficult to understand without that equation. With that equation, I can figure things out. But sometimes you don't have a nice equation. Sometimes you're just showing your data. And so if you don't have an equation and somebody just sees your figure, they're going to get really lost with this. So we need to find a way to make it accessible, to make it something that people can look at and be like, oh, I know what's going on. Yes, I can figure out what's going to come next. And we're going to do that is by making it a straight line. Or close to it, as close as we can get. Okay. So you're all looking at me thinking I know how to fix everything, and you're right, because I'm amazing. Okay. And very humble, apparently, too. Okay, now look at this data right here. And what you probably don't realize is that this is actually the same exact data. It's perfectly straight. It's actually not perfectly straight. It bends a little bit at the beginning, but then it gets straighter as we go up here. And you're like, what happened? Well, for different types of plots, you can scale the axes to make the data more accessible. Like with this one right here, I could just draw a straight line and figure out what's going to come next. And that'd be almost completely correct. With that one, couldn't do that. Now, there's a whole lot of magic when it comes to logarithmic plots, which sadly I can't show all of you. However, study up on these. They're amazing. The one little tidbit I will end with is, you notice how this is x cubed right here? If you look at it, when it gets to this section right here, it goes up 1, 2, 3 lines, and it goes over 1 line, a slope of 3. And if we look right here at the very beginning, it goes over 1 and up roughly 1. What this is saying is that at the beginning, this single term was dominating. And then at the end, this cubic term is dominating. So the slope of this line, when you look at orders of magnitude, these lines, the grid lines are created, is going to be telling you what power of x it is controlled by. I know that's a lot. You don't have to know that for this class. It's just one of those cool little details. And once again, I'm a good teacher, so cool is relative. Well, I'll see you all next time. We'll scale some axes together. Bye-bye.